Okay, so in this part of the lesson we're going to do some algebra. So we're going to look at expanding brackets, and in particular we're going to look for some patterns. Okay, so just to remind you of some algebra. If I wanted to work out a plus b all squared, then that is a plus b times by a plus b. A squared, ab, ba, or that's another ab, plus b squared. So I get a squared plus 2 lots of ab plus b squared. Right, what we're going to do now is look at a higher power, so a plus b all cubed, well that's a plus b times a plus b times a plus b, which would be the same as a plus b times a plus b squared. Now the reason I've written it like that is we've already worked out a plus b squared, that was a squared plus 2ab plus b squared. Now what I've got to do here is carefully expand the brackets, multiply a by each of those 3 terms, and then b by each of those 3 terms. Okay, so that's how we expand a plus b squared. That's how we expand a plus b cubed. What I'd like you to do now is have a go yourselves at expanding a plus b to the power of 4. Do that very, very carefully. Okay, pause the video and try that for yourselves. Okay, welcome back. So if you've expanded that and simplified it, then you should get the following expression here. The symbol here that I'm using is identically equal to, because these two sides are exactly the same, it's called an identity, and they're identically equal to each other. So if you've worked that out, then you should get this. Now then, what I'm interested in is being able to go further, so a plus b to the power of 5, a plus b to the power of 6, a plus b to the power of 7. Now the thought of expanding that by hand probably doesn't fill you with joy, so we're going to use a bit of technology to do this for us. So on your computer you have a piece of software called Derive. Just open that up. It's not the prettiest looking bit of software you've ever seen, but it is very, very powerful in terms of doing some algebra. So just to check a previous answer there, I'm typing in this input bar here at the bottom, a plus b to the power of 3, so I'm using the hat symbol there. Type puts that up for me there in a nice format. If I go simplify and then expand and just click on expand there, it does it for me. So that's what we found before, a cubed plus 3a squared b plus 3ab squared plus b cubed. So what I'd like you to do is open up Derive, check that we got the answer right here for a plus b to the power of 4, then work out a plus b to the power of 5, to the power of 6, and to the power of 7. Once you've done that, I'd like you to look at those results and see if you can spot any patterns. So pause the video now and we'll come back with some answers. Okay, welcome back. So if you've done that, then you might have some of these results here, and in fact I've put on I've started even at 8 plus b to the power of 0. Actual value is just got off the screen there, but that top one there is a plus b to the power of 0. Anything to the power of 0 is 1, so that's even got the 0th power there. So what we're doing here is we're looking for patterns, and obviously the first pattern that you should notice there is that we've got a triangle. But what about the numbers in that triangle? Well, hopefully you recognize those. We've seen them before, and they're the same numbers that we saw in Pascal's triangle. So that's going to be really helpful for us in terms of making these expansions. Let's just slide that across so I can see both of these on the screen at the same time, and what you'll see is they are the same numbers. So that's going to help us expanding higher powers of this bracket. So imagine that I wanted to expand x plus y to the power of 5. So to do that, I'm going to need the fifth row of Pascal's triangle, and those are going to be my coefficients. So I've got 1, 5, 10, 10, 5 and 1. Those are the coefficients that I'm going to need. To go in front of the terms that I've got. Okay. So first of all, we're going to have x to the power of 5 as my first term, y to the power of 0. I'm just going to put y to the 0 in there, although that's going to give me 1, of course. My second one is x to the power of 4, and then y to the power of 1. The third one is x to the power of 3, y squared, x to the power of 2, y cubed, and x to the power of 1, y to the power of 4, and then x to the 0 and y to the 5. So I could write that expansion out as x to the 5 plus 5x to the 4y plus 10x to the 3y squared, etc. So recognizing these patterns enables us to expand brackets. Right, I'm going to try another one here. So here's the example I want to try. I want to write down the first 4 terms of this expansion here. So I'm not going to write it all down, just want to see that I understand what I'm doing by writing down the first 4 terms. Well, which order is that? Well, we're going to do it in ascending powers of x. So we're going to have a units term, an x term, an x squared term, and an x cubed term. Right, so first of all, the power that we've got here is 6. So that's going to be the 6th row of Pascal's triangle. Let's just have a look at that again. The 6th row, 1, 6, 15, 20, 15. So the first 4 terms I want, it's those that I'm after. 1, 6, 15, 20. Okay, then I'm going to have 2 to the power of 6 minus 3x to the power of 0. I'm going to have 2 to the power of 5 minus 3x to the power of 1. I'm going to have 2 to the power of 4 minus 3x to the power of 2. 2 to the power of 3 minus 3x to the power of 3. Okay, so hopefully you've recognized that the powers of 2 are descending each time, the powers of x are ascending each time, and in fact another little visual check there is those two numbers, those two powers will always add up to 6. So what I need to do now is just simplify that, and then that will give me the expansion. So there we have the expansion. Remember, that's only the first 4 terms. There'd be an x to the 4, x to the 5 and x to the 6th term there. We're just checking the technique to see what we're doing. And we could check that using derive. If we type that in and ask derive to expand it, that's just quite a helpful way of checking we've got that right. It's doing it in descending powers there, but 64 minus 576x 2160x squared and minus 432x cubed is what we got, of course. Okay, I'm going to put some questions up now, and I would like you to do the same thing. I'd like you to find the first 4 terms of them in ascending powers of x, and then you can check your answers using derive. So what I'd like you to do is write down the first 4 terms in ascending powers of x of each of these expansions here. So there are 4 for you to try. As I say, if you can check those with derive, you'll know you've got them right. Okay, good luck with those.